Dear students and my teacher friends, Namaskar. I welcome you to the presentation lecture on the types of the synovial joint. Now, as you can see on the screen, I am showing you one table. And the reason why I am showing you this table is that with the help of this table during your exam days, you can quickly prepare all three types of the joint which are included in your medical entrance syllabus. For example, first type of joint, that is the fibrous joint. Then in your syllabus, you need to study the cartilaginous joint. Then today we are going to discuss the type of the synovial joint. So here in this table, as you can see, in the first column the name of the joint is given, then in second column description, the third column functional classification, and in the final column the example of the joint. So you go through this table. Then this is the remaining part of the table. Then in this table, the selected joints of the axial skeleton, then in this table, selected joints of the appendicular skeleton, now with the help of synovial joint, we can perform various kind of movement in our body. For example, gliding movement. Now, where this gliding movement is occurring, so gliding movement occur in the intercarpal and the intertarsal joint. So if you are interested, you can go through this information. Gliding between carpal with the arrows they are showing. Then you don't have to remember all this movement, but all this movement which we are performing with the help of various synovial joint. So for our information, we need to go through this. For example, the shoulder joint. So with the help of shoulder joint, we can flex our hand, then we can extend our hand, and we can hyper extend our hand. Then few more movement which are possible due to the various synovial joint. Here in this figure, shoulder joint and hip joint, rotation at synovial joint, special movement at synovial joint, now this table summary of movement at the synovial joint. Now this figure is very important for you. All the names you need to prepare, and this figure is covering all the 6 type of synovial joint. angular movement at synovial joint, angular movement, abduction and adduction, circular movement at synovial joint, circumduction, rotation at synovial joint, spatial movement at synovial joint, gliding movement at the wrist, angular movement, angular movement, flexion, extension, hyper extension at the shoulder and the knee, so now this is also very important figure for you. With this figure you can prepare all 6 type of synovial joint. Now we are starting our presentation lecture. This is the first point. Now the heading is type of the synovial joint. So synovial joints are divided into 6 categories based on the movement this joint are allowing. So plane joint, hinge joint, pivot joint, condylate joint, saddle joint, and ball and socket joint. These are the 6 type of synovial joint. Now first type in that is the plane joint. Now plane joint are also known as the planar joint. Now in the plane joint, the articulating surface of the bone is the plane one, or sometimes the articulating surface of the bone are flat or they are slightly curved. Now the plane joint enables back and forth and side to side movement between the articulating bones. Now between the flat surfaces of the bone, they may also rotate against one another. For example, here these are the carpals of our wrist, and between carpal, this joint is the intercarpal joint. So this one is the carpal, this shown over here, and this carpal is shown over here. And you can see both the carpal, they are having the flat or the plane surface, and that's why this joint is known as the plane joint, because the articulating surface of the bone is the plane one, is the flat one, that's why. And plane joint, they are non-axial. For example, the gliding movement are possible in the plane joint, that is the back and forth, this way and this way. So they can glide forward or they can glide backward, or side to side, side to side. This bone can glide this side or it can glide this side. So intercarpal joint, intertarsal joint, and the joint between the vertebral articular surface. These are the planar joint. Now here, when we are describing the synovial joint, you need to be familiar with some terms. Many times, see, synovial joints are either they are monoaxial, or synovial joint are biaxial, or synovial joint are the triaxial. Now with the help of ball and socket, I am explaining you. Ball and socket joint is the triaxial joint. Now the reason is, see, this blue color arrow is shown. This is one axis. So this axis is the superior inferior axis. So with the arrow, and in that arrow direction, we can move our arm. We can move our arm in this direction, that is the lateral medial axis, and we can move our hand in this direction, that is the anterior posterior axis. So since we can move our hand in three axes, our shoulder joint is the triaxial. Okay, so if synovial joint is permitting the movement on around one axis, so that type of joint will be monoaxial. If the joint permits the movement around two axes, that will be biaxial, and the joint permitting movement around three axes, then it will be triaxial. Now here, the plane joint are biaxial, that they are permitting movement in two axes. Now what is axis? So axis is the straight line around which a bone rotates or revolves or slides. Now if plane joints rotate in addition to sliding, then they are triaxial or multi-axial, because they are permitting movement in three different axes. That's why. Now here some information, if you are interested in the bone movement, you can understand with this what is gliding movement, what is angular movement, what is circumduction, what is rotation. You can go through this information. Okay, now the example of the planar joint. In our wrist, carpal bones are present. So between the carpal bone, the joint which is present is known as the intercarpal joint. For example, this is our wrist, and as you can see in the wrist, these are all carpals, and between the carpal the joint which is present is known as the intercarpal joint, and the intercarpal joint are the example of the plane joint. Now this is our ankle, and in the ankle we know there are seven tarsal bone, and between the tarsal the joint which is present is known as the intertarsal joint, and intertarsal joint is also the example of the plane joint. Now this is the manubrium of the sternum. This one is the clavicle. So the joint which is formed between the clavicle and the manubrium is known as the sternoclavicular joint. With the box, they are showing the sternoclavicular joint, and this sternoclavicular joint is zoom over here, sternoclavicular joint, and this sternoclavicular joint is the example of plane joint. Now this is the scapula. This is the acromion process of the scapula. This one is the clavicle, and as you can see, this part, this joint between the acromion and the clavicle, this joint is known as the acromioclavicular joint, and acromioclavicular joint is also example of the plane joint. Now here, sternocostal joint. Sternocostal joint, this is the sternum, this one is the sternum. These are the ribs, second, third, fourth, fifth, sixth and 7. And these are the costal cartilage. These are the costal cartilage of second to 7th rib. And this costal cartilage, they are making the joint with the sternum. So the joint between the costal cartilage and the sternum is known as the sternocostal joint, and the sternocostal joint are the example of the plane joint. Now, vertebral costal joint. Now here, this is the 7th rib. 7th rib is shown. This one is the head. This one is the head of the rib. And you see how the head is articulating with the body of 6th thoracic vertebra and the 7th thoracic vertebra. Now this is the, we know this is the inferior demifacet of T6. This is the superior demifacet of T7, and the head of the 7th rib articulate with this inferior and superior demifacet, and the joint which is made between the body of the vertebra and the head of the rib, this joint is known as the vertebrocostal joint. One more joint is here. This is the 7th rib. This is the tubercle of the rib, and transverse process is having a facet. So this tubercle fits into the facet of the transverse process. So the joint which is formed between the tubercle and the facet of the transverse process, is known as the costotransverse joint, and this joint is also vertebro-costal joint. So these two joints are example of plan joint. Plan joint. Now the hinge joint, the other name of hinge joint, jingly mus. Now in hinge joint there are two bones are participating. One is having convex surface, another one is having concave surface, and this convex surface fit into the concave surface of other bone. And as the name suggests, hinge joint permits angular movement, opening and closing motion, like the hinge of the door permits the movement or the allows of the movement of the door. So hinge is fixed in the door and the wood part of the door is moving. So that thing, same way, one bone is acting as the hinge and the other bone is moving like the door. That is the hinge joint. So one is fixed and other bone is moving. Hinge joint is the uniaxial or monoaxial because it is allowing the movement of the bone in the single axis. That's why. For example, over here in this figure, this is the humerus. Imagine humerus as the metal hinge and ulna is like the door. So the door is moving either this side or this side. Okay, this is the humerus, this is the ulna, and this can move either this way or this way. So movement is possible in only one axis. That's why this joint is the monoaxial joint. Example of hinge joint: elbow joint, knee joint, ankle joint, and interphalangeal joint. Now here in this figure, the elbow joint is shown. This is the elbow joint. And as you can see, the elbow joint is permitting the flexion of our hand, and the elbow joint is permitting the extension of our hand. So it is, the elbow joint is like the hinge. Okay, now knee joint, extension, flexion. Okay, then moving on the point number 13. Now the pivot joint. Now pivot joint is also known as the trochoid joint. Now here in pivot joint, what is happening? See, in pivot joint, two bone are participating. One is ulna, other is radius. Now the radius, the head of the radius, as you can see, it is the rounded one. It is circular one. So this circular head, this surface is the convex, and the ulnar surface is the concave one. Convex surface is fitting into the concave surface of ulna, and both the bone, they are tied by the ligament. So right now I am showing you the ligament. Okay, and This is the axis. So imagine the ulna is acting as the axis and the radius is rotating. So the only movement, that is the rotational movement, is possible in the pivot joint. So the movement is possible in one direction, only the rotational movement is possible. So that's why the pivot joint is the uniaxial joint, and the example of the pivot joint, that is the proximal radioulnar joint and atlantoaxial joint. Now here one more example for the pivot joint. This is the first cervical vertebra, that is atlas. Second cervical vertebra, axis. We know axis remains stationary and the atlas is rotating on the surface of the axis. And the movement, let's say this is the axis and this arrow is showing the movement. Here this is the movement of the atlas. So the atlantoaxial joint is also example of pivot joint. And due to the atlantoaxial joint, we can shake our head and we can say no. The reason is axis is stationary and we can move left and right our head and we can rotate the atlas. So with the arrow, the movement of the atlas is shown. So here in this figure, as you can see, this girl is saying no, and the reason why she is able to say no is the atlantoaxial joint of first and second vertebra. So atlantoaxial joint and the radioulnar joint are the example of the pivot joint. Pivot joint. Now next type, condylator joint. Condyle means knuckle. This joint are also known as ellipsoidal joint. Now in this type of joint, two bones are participating. One bone is having convex oval shape projection and the other bone is having oval shape depression. Condylator joint is biaxial, that the joint is permitting movement around two axes. For example, this is the metacarpal bone and this one is the phalange. So the joint between the metacarpal, this joint we are talking about. So as you can see, metacarpal is having convex surface and the phalange is having the depression. And in this joint, the movement, two type of movement are possible. Let's say this is the axis, so medial lateral axis, and the bone can move either in this direction or in this direction. Okay, so forward and backward. So flexion and extension possible, and on this axis, anterior posterior axis, abduction and adduction is possible. Condylitic joint. So example, condylitic joint, metacarpophalangeal knuckle joint and wrist joint. This is the wrist joint is shown in this figure, and you see this is the palm is shown, and palm with the finger. And if our palm and the fingers they are straight, then we have extended our palm, then we are bending it vertically, so it is the flexion position, and when we are bringing our palm down, then it is the hyperextension. So hyperextension, extension and flexion in the wrist joint are possible. So wrist joint is the example of the condylitic joint. Then this in the wrist joint, once again the palm and the fingers are shown, and we can move left right. So abduction and adduction possible. Then here you see all the fingers are together, that position adduction. All the fingers of our hand they are spread, that is abduction. So abduction and adduction, this type of movement is possible due to the metacarpophalangeal joint of the fingers, not the thumb. Now one more example of the condyloid joint is the radiocarpal joint of the wrist. So here in the figure you can see this is the radius, this is the radius, and these are all carpals. So between the radius and the carpal, the green color joint which is shown is the radiocarpal joint, and this radiocarpal joint is the example of condyloid joint. Now these are the phalange, of our finger, and these are the metacarpals. So between the metacarpal and the phalange, the joint is known as the metacarpophalangeal joint. So this metacarpophalangeal joint is example of condyloid joint. Now next type of joint, that is the saddle joint. Now saddle joint is also known as the sellar joint. Now here in saddle joint, one bone is having the articular surface like the saddle. Now what is saddle? First of all, let's say this structure is look like the saddle. Now you might have seen the saddle when you are doing, if you have in past, if you have enjoyed horse riding, so when you are doing the horse riding, you are sitting on the saddle, and the owner of the horse arrange this saddle on the back of the horse. So when we are doing the horse riding, we are sitting on the saddle, and this thing you can imagine, these are our legs. So when we are going to sit on the saddle, we are spreading our leg, so our leg are going to fit into the saddle of the horse. So similar way, saddle joint is present between the carpal trapezium bone and the first metacarpal of our thumb. First metacarpal of thumb and the trapezium carpal. Between this, the saddle joint is present. So trapezium is having the saddle surface, and the metacarpal is having the concave surface. So this concave surface is going to fit onto this saddler surface. Now saddle joint is permitting biaxial movement. So this is the axis. This axis is the medial lateral axis, and the abduction and the adduction possible. This is the anterior posterior axis, and flexion and extension of the bones possible. So for saddle joint, the example we are remembering, carpo-metacarpal joint between the trapezium of the carpus and the metacarpal of the thumb. Okay. Now the final type of joint, that is the ball and socket joint. Ball and socket are also known as the spheroid joint, and here one bone is having the ball-like surface and the other bone is having the cup-like depression. So this ball-like surface of one bone fits into the cup-like depression of the other bone. For example, in our shoulder joint, the humerus of our arm, here you can see the head of the humerus is the ball-like, and the glenoid cavity of the scapula is the cup-like depression. So this circular head of humerus is fitting into the glenoid cavity of scapula, and the joint which is formed is known as the shoulder joint, and this shoulder joint is type of the ball and socket synovial joint. Now in this ball and socket joint is actually, it is the example of triaxial or the multi-axial joint. Ball and socket is known as the triaxial or the multi-axial joint. The reason is, you see this figure, so you will find that with the ball and socket joint, abduction of arm, that is the spreading of our hand, is possible. Then the flexion, we can flex our hand, and we can also rotate our arm. So three type of movement, abduction, flexion and rotation, are possible. So that's why ball and socket joint is the triaxial or the multi-axial joint. Now this point I have explained to you. And the last joint, that is the hip joint. This is the exact location of the hip joint. this is the theory point, and now I am explaining. This is the thigh bone, femur. This is the this one is the head of the femur, and this is the acetabulum. This one is the acetabulum of the hip bone. So the ball like head fit into the acetabulum, and the joint which is formed between the head of the femur and the cup like acetabulum, that joint is ball and socket joint, and this is the hip joint. So hip joint is also the example of the synovial joint. So with this, we have completed this presentation lecture on the types of the synovial joint. I hope you have enjoyed this presentation lecture, and I also hope that this presentation lecture will be helpful in your exam preparation and also in your studies. My name is Manish Kushti sir. I am from Ahmedabad, India. Bye bye. Namaste.